I'd like to move on to our next case study, the second case study, and this is coming from New York in the United States. And I'm very pleased to have Alex Marshall joining us, and he's the Group Business Development and Marketing Director in the US for Clarke Energy. Alex, you have the floor.
Thank you for that introduction, Hans, and really good presentation there by Roberto. I particularly agree with the comments on how CHP will be fitting with other technologies in the future. We're not just a standalone industry. How does CHP fit within the wider context of other power generation and storage technologies? So taking that presentation on a step further, we've discussed trigeneration, electricity, heat and cooling recovery from a gas engine. Here we're going to go to quadgeneration. So this is electricity, heat, cooling and carbon recovery from a gas engine and other technologies. I'm going to give you an introduction in particular to our latest project, our second project in this instance for this technology, at Liberty Coca-Cola in New York. So firstly, I'll give you an introduction to Clarke Energy and who we are, an outline of the different types of CO2 recovery technology for CHP units, and also, as an aside, biogas upgraders, and then the detailed look into the Liberty Coca-Cola project. So as a business, Clarke Energy operates in 27 countries, with the largest distributor for INEOS Yanmbaca gas engine range globally. We help to support net zero, the transition. We help to deliver resilient power generation installations. We support the lowering of costs and carbon emissions. Even natural gas fueled CHP can deliver tangible carbon savings in many countries till the early 2030s. That's before you take on board the renewable fuel options. As a business, we deliver turnkey power solutions, turnkey EPC, and we come from the after-sales support business. So globally, this is where we operate. So we really do have a global view of many different drivers for CHP in different countries, whether that is underpinned by tariffs in France, whether it's the business case in the UK, the Inflation Reduction Act in the United States, or delivering resilient power in remote locations in Australia, Africa, and supporting low-cost generation in countries like Bangladesh. So, picking up on the integration of where CHP fits, there's a number of different other technologies that are now complementing CHP. CHP, I believe, has to move from a baseload generation technology to a flexible generation technology, and that can be fueled by natural gas or propane on the fossil side, but more and more biogas, biomethane or RNG in the States, and hydrogen. And also integration of not just the CHP with electrical power generation technologies, so wind, solar has been mentioned already, backup gas units or energy storage, but also thermal recovery. So heat pumps, how CHP integrates with heat pumps, thermal stores to give a holistic solution for both electricity and heat. So on carbon dioxide and conversion and recovery, the first technology that was recovering CO2 for use for many years was in the greenhouse sector, widely deployed in the UK, in the Netherlands, and many other countries. Here, the engine exhaust is passed through a catalytic converter with the addition of urea. That helps to take the NOx out of the engine exhaust, and that can be pushed into greenhouses. Those greenhouses then having higher CO2 in the growing air, which promotes the growth of the plants. A nice solution for the greenhouse sector. As a slight aside, on biogas upgrading, where you're taking a biogas, which is primarily methane and carbon dioxide. Carbon dioxide is much higher concentration than an engine exhaust, which is typically under 10%. In this instance, you can strip out the CO2 and distill it, and then cryogenically store it and have the production of dry ice. And that picture in the bottom right-hand corner is of a recent project in France with methane. So CO2 is notoriously difficult to visualize, but I think that's a really nice picture of how CO2 can be recovered from an adjacent technology. Another CHP technology where we're doing proof of concept, this time in the UK, is advanced mineralization. Here the engine exhaust is treated with an alkaline solution with the addition of brines. that absorbs the CO2 into solution, and that CO2 can be precipitated out as high-grade calcium carbonate or calcium magnesium carbonate, which is a high sale value. This is a proof of concept, and we anticipate having our first units of these installed in the next year. Maybe we can do a deeper dive into that technology next year. And then, so the subject we're here to talk about primarily is Quadgeneration. The system you see in the bottom right-hand side was the first project we delivered. This one was in Knockmore in Northern Ireland. Here you recover the engine exhaust and pass that through, firstly, selective catalytic reduction with the addition of urea, taking on board the greenhouse technologies used originally. Then you pass through an absorption tower, a stripper tower, amine-based systems, and a reboiler, which then helps you to recover the CO2. So what is beverage grade Quadgeneration? So, CO2 recovery can be done to different levels. If you're going to use this in a consumable product, it has to be literally at the very highest standards, because it's going to go into a product that is consumed by humans. So firstly, it's built using a proven amine-based technology. Amines are highly selective for the absorption, or these amines are highly selective for the absorption of CO2. The other benefit of this system is you can take CO2 sources in exhaust gas, which is notoriously low concentration CO2, and it's also very hot. So, you've got these two problems with recovering it: very hot gas and very low CO2 levels in that gas. It is done in a relatively small footprint. It's completely independent, and it gives you an on-site production source for carbon dioxide, which, the main driver in this instance is offsetting CO2 that is typically procured from other countries. And in the recent energy crisis, we've seen CO2 prices, ironically, considering we have too much in the atmosphere, reaching very high levels. So there is a drive for localized production of CO2, along with high efficiency electricity, heat, and cooling reduction. So, and that in essence is a reducing factor for carbon dioxide emissions. So to dig into Liberty Coca-Cola's project, this is a site just north of New York at an established manufacturing facility for Liberty Coca-Cola. This is a site in Elmsford in New York State. So what the system looks like, we are breaking ground this week. So it's going to be an exciting few weeks, and we anticipate the construction of this over the next year. With the anchor technology here is two of INEO's Yambaca CHP engines. You have the engine exhaust being passed into firstly a scrubber tower, a stripper tower, and then you have the CO2 recovery storage tanks. So firstly, we've got the kind of more in-depth look at the process. So firstly, selective catalytic reduction helps to remove NOx. The NOx in this instance is a problem for the amine itself. So this helps to make sure that the amine life is kept up. Next, you have the exhaust being fed into the top of the scrubber tower. The scrubber, which has a combination of amines, specific amines tailored to the absorption of CO2, along with sodium hydroxide, with gravity filters helping wash the gas. The second stage scrubber gives a second wash, and then you have the solution passing through a stripper tower. The amine is heated, that liberates the CO2, and then you have further polishing and recovery of any contaminants and odors that may be in the gas, so you have the highest grade purity of CO2. This particular instance needs to be to Department of the FDA beverage grade quality to be certified. And then you have moving to a storage tank. So what are the advantages? Firstly, a high CO2 reaction rate and a high recovery rate of CO2 from the exhaust gas, reaching around about 90%. The technology is highly tolerant of different oxygen content, which is another problem in the gas, or another challenge in the gas. You've got a lower energy demand for the regeneration, which can actually utilize some of the exhaust heat from the surplus heat from the engines. You've got a lower total energy demand for the process, along with recovering the carbon dioxide as a useful product. So, in a nutshell here, my view on this is CHP sits in the energy transition as an ability to deliver both resilience and carbon savings, whether that's natural gas as mentioned before, but more and more hydrogen, biomethane, biogas, all of which are proven fuels for CHP. And then if you do have a carbon-based fuel, you can recover the CO2 from natural gas to give you a close to zero carbon emission level. Or if you recover CO2 from biogas, as biogas is a short-term carbon cycle source of carbon, you can help to net reduce carbon dioxide in the atmosphere. If you'd like to contact me, learn any more about this, my contact details are below, my email and my telephone number. Thank you very much.
Thank you. Thank you very much, Alex. That was a very interesting presentation, and it flows very smoothly from trigeneration to quadgeneration.